This video introduces switch transformers for large neural networks. Switch transformer applies a mixture of export into transformer by maximizing the number of transformer model parameters to improve computational efficiency. The feed-forward network layer in the regular transformer is replaced by a sparse switch feed-forward network layer. Given the input token X, only one export is selected to generate output that is gated by the routing gate value. The significant difference from MOE is that switch transformer routes one token to one single export. MOE takes token X as an input and then selects the top key exports from a set of n exports. The gate value for export I is given by softmax function, where hx is a similarity score that indicates how export is related to the input token X. MOE selects the top key exports together to map the input token X, namely calculate output by using sum of products between the output generated by the selected exports and the route gate value G. However, the n exports are competitors, not cooperators. Switch transformer only uses a single winner for one token to generate the token representation. Namely, calculate output uses the output generated by one selected export and the route gate value G, which preserves model quality and reduces the routing computation. An auxiliary loss is used to encourage the balanced load across the export for each switch layer. Auxiliary loss is added to the total model loss during training. Given n export and batch B with T tokens, the auxiliary loss is defined as a skewed dot product of vectors Fi and Pi, where Fi is a fraction of tokens dispatched to export I. For example, given T input tokens, if the export I can cover M input tokens, and this sum is equal to M. For a uniformly dispatched distribution, this M can be written as the T divided by N. Ideally, this Fi is equal to 1 divided by N. Pi is a probability fraction of export I across all tokens in the batch B, where G is a normalized probability, namely sum of this G over the N export is equal to 1. Given M input tokens, if the export I has 100% probabilities to be selected, and then this sum is equal to M. Again, now for uniformly dispatched distribution, this M is written as T divided by N. Ideally, this Pi is equal to 1 divided by N. The goal is to seek uniform routing across the N export, namely, the desired auxiliary loss is equal to a small learning rate alpha. For more details, please check with these references. Thank you. Bye.